rational solution. Now this piece right here, it means the very same thing as just root 6 3 times, right? Root 6 times root 6 times root 6. Okay, and again, I'm sure a lot of you see that, but the properties of exponents lead to this truth right here, and root 6 times root 6 is 6, which explains this term right here. Okay, folks, now we are starting with a linear system up here, or a nonlinear system with irrational constants. So we're going to try to find the product xy without actually determining the value of xy. So you can see this very first statement, everything follows. We get 162 root 6. Now, standard technique in mathematics is to just do two expressions, get two different things, and then equate, and that's what I did. See, x minus y quantity cubed by the binomial expansion is also equal to this, but notice 3xy is common to both terms right here, so this would actually be, I guess, a lot of people like to call this the greatest common factor, and that's actually a very big step into determining the solution to this, because we are, after all, looking for xy, right? And there it is, there's xy. Now the rest of this, folks, is again equating equals. You see the green expressions that I've done for you right here? That's all I'm doing right here, is equating the green expressions. Okay, I'm equating the green expressions on this line right here. But notice the last piece of information that we did not use is getting used now. We're given that x cubed minus y cubed is equal to 702 root 6. That's where this 702 root 6 comes from. Now the very next part of this, I'll just write it down underneath here. This would end up being, if you bring this to the other side, it's just the way I'm going to arrange it, you would get 9 root 6xy. And y'all, it's just the way I'm doing it. There's a million ways to do it, but well, probably not a million ways, but you see, you can bring this negative value after multiplying the 3 over to the left-hand side, and then all you have to do now is subtract 162 from 702, and that ends up being 540 root 6. I think this method is really, really cool, because we're never really determining the concrete values, irrational values of x and y. Okay, everybody comfortable so far? And now y'all see how nice this works out for us? 9 is a divisor of 540. It's 60, right? And the root 6's, of course, cancel. And so what we get right here is the product xy equals to 60. Again, I love it. I love it. We don't have any idea what the values are of x and y. We could find them in a couple of steps using the quadratic formula, I suppose. But in any event, we found the product, which is what we were trying to do. And I hope you like that one.